Welcome to this review of ESG Lab's hands-on testing and performance auditing of the DataStream 1000 from Coho Data. When ESG asked IT professionals about their biggest storage challenges, their list was topped by the rapid growth and management of unstructured data. This ongoing and growing issue stems partly from the increasing creation and consumption of content using mobile devices, but of course generally there's also an avalanche of data from pictures, video and day-to-day business documents. Other key storage challenges included hardware costs and data protection, and notably, a quarter of the respondents also cited running out of physical space, needing to support growing virtual server environments and data migration, which, if you think about it, are all likely related. As organizations run out of space for their growing VMs and unstructured data, they must migrate to additional storage in order to support it all. And that tends to be time-consuming and disruptive. ESG Lab recently tested the Coho DataStream 1000. This is a scale-out, high-performance NAS storage solution, and it's modeled in something of a pay-as-you-grow public cloud economic paradigm, designed for an enterprise's on-premise private cloud. Using commodity hardware and a modular building block deployment makes it easy and cost-efficient to scale, while distributed system software presents the whole cluster as a single data store to the application servers. Furthermore, the innovative architecture combines storage logic into a 10 gig E networking layer using software-defined networking. In plain English, this flattens traditional silos and allows scale-out without the usual associated bottlenecks. In this high-level schematic, application workloads are on the left, connected to the Coho-enabled switch. It has DataStream software to handle data placement and routing, and the management web interface is shown above. On the back end are Coho's modular microarrays interconnected via the 10 gig E switch. The microarray building block uses a 2U commodity server and contains 2 microarrays. This gives a balanced ratio of CPU and network bandwidth to fully utilize the included high-performance Intel PCIe SSDs. To balance the relative expense of flash, the microarray also has regular disk drives and a data hypervisor that provides automated data tiering. It also manages replication of the data across the cluster, which eliminates the need for traditional RAID to counter the impact of drive failures. In fact, recovery from such a failure happens faster because all the microarrays in a cluster participate in the rebuild. At the top of this diagram, you can see that application-specific data profiles help define and deliver their precise storage requirements, which tunes performance, durability, tiering, and replication. These profiles are implemented by the DataStream service, which includes protocol services, placement, routing, and load balancing, and which is all run from the Coho software installed on the switch, which is an OpenFlow-enabled commodity 10 gig E switch that presents a single IP address to the application server, for example, a vSphere cluster. DataStream's ability to support a range of data profiles eliminates the usual effort required to create different storage tiers for different applications, which makes the Coho solution more of a cloud-style service, adapting to different and changing application needs. Within a VMware integration, administrators can tag each VM at creation with a particular data profile, for instance, high performance or test and dev, and the system automatically delivers the correct performance and resilience. ESG Lab started by testing the basic deployment, configuring the Coho software that is pre-installed on the switch, and initializing the storage microarrays behind it. With the switch powered on, we logged into the simple configuration wizard by adding and confirming our password. Standard network management details were factory pre-configured, including the management IP address, gateway, netmask, DNS server, and private storage subnet. After confirming these settings, we had the option of configuring a VLAN, as well as email or SMTP notifications. Next, we simply added vCenter credentials to provide connectivity between the Coho solution and our VMware hosts. After confirming these settings, we clicked Start Installation to complete the process, and we were able to log into the management interface. We powered on the storage chassis and monitored the initialization of the 2 microarrays contained within it. This process provisioned all the resources for both microarrays, including the hypervisor OS, network, and storage. You can see here the component detail of each microarray, including CPU, network, flash drives, and spinning disk. At this point, we were ready to create an NFS data store from the DS1000, so we logged into the vCenter and, using standard network and storage configuration tools, provisioned our Coho VMFS data store, on which we deployed several VMs. It took only 5 minutes to configure the switch, watching and chatting, not clicking, and the entire boot process was a mere 15 minutes from scratch. ESG Lab validated over 173,000 IOPS using a single 2U chassis running a random 4K workload of 80% reads, such as you might see with OLTP. The performance scales as microarrays and chassis are added, with 10 full chassis achieving just under 880,000 IOPS. As is probably obvious by now, it scales without bottlenecks because each added microarray also adds CPU, network ports, flash drives, and disk, while data placement and load balancing continue to take place at the network layer via the DataStream service. Throughout, we recorded an average latency of 12.5 milliseconds, and as a point of reference, Microsoft guidelines are that a latency of 20 milliseconds or less means no perceivable performance delay for Exchange users. Finally, we wanted to validate that performance could scale in real time, since real users would add individual microarrays over time. We began with 80 VMs running a Linux-based file I/O utility on a single chassis, shown here on the left side. As we added each microarray, the Coho solution added the capacity and redistributed the workload in under 10 minutes, enabling the VMs to use the additional capacity and IOPS without any additional effort. In this chart, you see that the performance increased stepwise. In only 2 hours, we scaled from 2 microarrays to 20 microarrays and found that the workload was rebalanced evenly each time. Simply put, Coho users will get predictable performance as they grow their environments over time, and with minimal management effort. So why does this matter? Because Coho is removing many of the storage provisioning roadblocks and configuration challenges that enterprise IT professionals face daily with traditional monolithic storage. It's doing so by bringing public cloud pay-as-you-grow and scale-on-demand paradigms into a secure private cloud infrastructure, with bottleneck-free, high-performance, application-tuned NAS storage that operates like a service with fully automated data management services like tiering and replication. It means you don't have to worry about RAID and LUNs and array configurations or the resource bottlenecks created by inefficient scaling. And Coho is doing all this on cost-effective, commodity server and networked hardware that integrates flash with traditional disk so that the system can be considered for general-purpose, virtualized and non-virtualized application storage, not just high-end workloads. ESG Lab put this solution through its paces. We logged in, configured and deployed a single chassis in around 20 minutes. We believe the DataStream technology is designed to scale without bottlenecks, and our testing confirmed both performance and scalability. As Coho Data is just coming out of stealth, it remains to be seen how its technology will prove itself in the field over the long haul. But with good execution, we believe the solution provides a promising and intriguing new approach for enterprises to deliver internal storage services in powerful, scalable and efficient ways, and thus challenge the notion that public cloud storage is the only route to economy and flexibility.